We live on a planet that is mostly covered by water. In fact, water covers around 71% of the surface of our planet, and to an average depth of over 3 kilometres. This is of course very useful, since as far as we know, all life depends upon the availability of liquid water. Now, around 97% of our planet's water is contained in our seas and oceans, with about 2% remaining as ice and 1% in our rivers, lakes, swamps or under the ground. So, this is a good point to introduce the two broad categories of water we will be talking about today. And that is salt water and fresh water. Fresh water contains very low amounts of dissolved salts and other dissolved solids. It is contained in our rivers, in ice caps, glaciers, lakes and in underground stores such as porous rocks and fractures in rock formations. The moisture in our air, whether it be as vapour, clouds, mist or rain, is also fresh water. Salt water is by far the most abundant on our planet and is mostly contained in our seas and oceans. It contains higher levels of dissolved salts, which makes it unsuitable for drinking or for use in agriculture, certainly without treatment to remove the salts first. When talking about fresh water, there is one term you must be able to recognise and use correctly, and that is groundwater. Now, despite its name, it's perhaps best described as underground water. In fact, around 30% of all our fresh water is hidden away as groundwater. We tend to only see it when it bubbles up to the surface at springs, but we access it mostly by digging wells and then pumping it to the surface. When we do this, we're accessing something called aquifers, which is just a technical term to mean underground layers of water-bearing substrate. Now, you might be expected to recognise that term in a text in the exam, and so it is a good one to add to your vocabulary. For us, however, as humans, there is one category of water that is more important than any other, and that is something we call potable water. This is a technical term used to describe water that is safe to drink. Potable water is a specific category of fresh water in that it contains low or very low levels of dissolved salts, but it is also free of dangerous levels of bacteria and other harmful substances. Now, I've got a bit of a love of unusual words, and potable is certainly one that we don't use in general conversation. But this one comes from the Latin word potare, which means to drink, and then it later became potabilis, which meant drinkable. Potable water is in short supply. Around 1/3 of our global population do not have access to potable water on a daily basis, according to the World Health Authority. And that is certainly something you could think about the next time you turn on a tap. There is one final category of water a UK examiner might expect you to be familiar with, and that is pure water. Now, this is different to all of the above types of water and has a very specific scientific definition. Pure means only, in the sense that a sample of pure water would contain only H2O molecules. In realistic terms, this will never exist, as there will always be a tiny amount of something dissolved in the water. but modern laboratory-grade deionized water comes close. In the next video, I will be looking at how we turn fresh water from aquifers, rivers, lakes and streams into potable water. For now, make sure you're familiar with those key terms: saltwater, freshwater, groundwater, potable water and pure water, including their definitions and the places that you might find them. And I will see you next time. Until then, take care. Bye-bye.